Hey, all. Hope you're doing well. Welcome back. Yesterday, of course, we learned about a little bit about how a power plant works, how a generator uh, generates the electricity through electromagnetic induction, and how that can happen at a power plant with a turbine spinning. And specifically, they focused on the hydroelectric plant. You probably saw a little video about that. But they all work on the same concept, whether it be coal or nuclear energy. Uh, in those cases, of course, they're heating up water and they're making steam to turn that turbine. The wind, of course, literally the wind directly turns the turbine. And in all those cases, the generation of the electricity uh, follows the same pattern. Today, we're going to look at, well, how do we get that electricity from point A to point B? Because having it at the power plant doesn't do us a whole lot of good in our homes. And so that's where electrical transmission and distribution come into play. You'll hear a little bit about what we call the electrical grid, and there will be a little clip to watch on that. And one of the key players in that whole process is something called a transformer. Not a robot in disguise. I know there's a nice series of movies and they're fun and all, but in this case, a transformer is going to be a device that's going to change the voltage of the electricity. You can either increase the voltage or you can decrease the voltage. Something called a step up transformer, as the name might indicate, is going to increase the voltage. A step down transformer will decrease the voltage. Step up transformers do this with a design where there are more coils of wire in what we call the secondary coil than the primary coil. And we'll take a look at a diagram shortly and hopefully make some sense out of that. And that's going to be critical in terms of the efficiency of transmitting that electricity. Step down transformers are just the reverse, where you got fewer coils in the secondary coil than the primary coil. And that's going to be critical for lowering the voltage as it comes into people's homes. Another one of the key themes to look for is that this only is going to work, a transformer only works with what we call alternating current, not with direct current. As I look at a transformer, you probably have seen them outside your homes. You look up on the power lines, maybe you've seen kind of one of those gray looking buckets. Maybe you weren't sure what that really was or what that did. Well, that is a transformer. And that is going into your home is going to be a step down transformer. They want to decrease the electricity coming into your homes in terms of the voltage. All right. And now, if I look at this other diagram here, you've got looks like a square iron with a hollowed out center, and that is going to be kind of what the interior of that transformer is going to look like, where you've got what we call the primary coil, where the electricity from the power plant, for instance, is coming from, and it's got coils of wire, and those coils of wire, of course, will run electricity through them, and you'll notice in the secondary coil there are fewer coils. All right, that's to decrease the voltage, so there's less voltage going out as there was coming in. Now that all happens because in an alternating current at the power plant, those magnetic poles, they're spinning very fast. They're spinning 60 times every second. It's called 60 hertz. And so with each spin, you're rotating the magnetic field, you're rotating the magnetic poles, and so you're changing the direction of the current. You're alternating that current with every one of those spins. And so that's how the concept of a transformer will work. If you have fewer coils, you create less voltage. That was Faraday's law when we talked about moving magnetic fields by a conductor. And it's all coming into play here. Now, if this were a direct current, like from a battery, you wouldn't be able to make this happen because you'd run electricity through the coil, that primary coil, and you'd make a nice electromagnet, but the fields would not be changing, the poles would not be changing, and so you wouldn't induce a charge on the other coil. Now, stepping up the voltage for transmission from the power plant is important because it's going to save energy. If you remember a formula we gave you, the P is equal to I times V, or the watts is equal to the current times the voltage. So if you increase the voltage, you'll notice that the current is going to go down, which might seem counterintuitive in terms of the what you'd want in the power lines, but actually, when there's less current in the power lines themselves, you're going to decrease the loss of energy because of that would be lost during the resistance in the power lines. All right. Now, with a transformer, then I can make that happen. I can increase my voltage coming out of the power plant, and then, like we already showed you, we can decrease it going back into our homes. And it only works with alternating current, with the magnetic fields changing back and forth. Well, this led to one of the famous scientific battles in history between a couple of very brilliant scientists, Nikola Tesla and Thomas Edison. Tesla was very much in favor of the alternating current method because of the idea of transmission. Thomas Edison had invested a lot into what's called into direct current and direct current generators, and while he was very much against the 8-ball in terms of the science involved, financially it was much to his benefit in order to if direct current was chosen. And so there's a video that we're going to have you watch that's going to document a little bit more of this history. But Tesla, fascinating character, a little bit of a mad scientist, but brilliant. Some of the whole being able to transmit energy through the air and remotely is all very much tied into what he did. So today the plan is I want you to read about the electrical grid on our online text. There should be a link on Schoology for you for that. And there's a couple little simulations and that you can follow through for that. There's also going to be a video about the Edison-Tesla rivalry, just a real interesting history lesson there, as well as science. We'll take a quick quiz, and you're done for the weekend. Have a great weekend. We'll see you next week.